Okay, we're going to talk about slope today in section 6.4. Super important lesson. We're working with lines, and we know that lines have a slope. When you think about slope, have you ever used slope to do something fun out there in the world? Yeah. When is it fun to use slope? Like, what activity were you doing? Well, sledding. Anybody else sled or used an inner tube on the snow? That type of thing? Okay, a bunch of people have. And the other thing you could have done was snowboarding. Anybody snowboarded? And how about skiing? Good. So almost everybody has done something like that. If you weren't on snow, could you skateboard?
Yeah.
Skateboarding on a slope is different than on a flat land, right? I mean, flat has its own, we could call that a slope, but it's just very flat. You're not going to go so fast. Imagine going down Encinitas Boulevard here on a skateboard. You know, you could really pick up some speed, and you definitely don't want to come off your board at a high speed, right? So same thing with biking. We could talk about slope with riding a bike. And again, if it's a really steep slope, there's more speed involved probably, right? And surfing, right. Have you seen the recent waves, like the 100-foot waves? Yes. There's been a recent one, some amazing videos out there of people riding those huge 100-foot waves, you know. So a guy got, actually, a famous surfer died recently. Anyway, because if you get thrown off that wave and you're under for a long time, it could not be good. Sometimes they actually wear preservers, life preservers, or they have an emergency. Yeah, they can pull it if they are still alert enough to do that. So slope. When we talk about slope, before we put the definition of slope down, let's look at a slope here. Look at this. This is kind of a wedge, a triangular looking thing. And we could imagine that this line that's kind of tilted is a slope. It's a ramp, right? So what would the slope be of this ramp? So what do we consider when we're finding the slope? What things must we consider? This is the ramp, imagine, okay? And then you see these other numbers and these other sides that make it look like a triangle. And they really affect the slope, don't they? So how do they affect the slope? Audrey?
Well, we have to figure out the perimeter.
It's not about the perimeter, but it's about what, Ada?
The angle.
It's about something about the angle, right? Like if you wanted to move a big, heavy item up from the ground, up to the windows here in our classroom, and I had a really heavy item, if I went really over here close to the window and lifted it straight up, that would require a huge amount of strength, right? And if it was, instead, I built a ramp that came clear over from this side of the class and gradually went up, I could kind of drag that item up, right? What would be the factors that are making a slope? You can see them in this picture. Brian? What? So it's kind of the length that you're going. So we have a length that we would be dragging something up a ramp, right? And we have this part here, which is really the height, right? The steepness, the how high are we lifting an item? So the two things that we need to consider are how far do we have to move something and how steep we're lifting it, okay? And so on a coordinate plane, what value is going up and down? Is it the X or the Y?
Y.
It's the Y. And what value is going across horizontally? The X. So we're looking at the change in the Y value, and we're looking at the change in the X value, right? And so if we were going to find the slope of this ramp, we could put the change in the rise over the change in the run, and that will give us a slope. What is the rise in this example? Everyone? 6 feet, right? And what is the run? How far across? 18. So we can say the slope of this ramp is 6 up and 18 across. 6 over 18. Could we reduce that fraction? We could divide them both by what? And we would get 1/3. So we could say the slope of this ramp is 1/3. For every 1 foot up you go across 3 feet. Okay? So whenever we're considering slope, we are considering the height and the horizontal distance. The change in the height over the change in the horizontal distance, okay? The letter we use for slope is M, and that's kind of easy to remember because where do you do all that skiing and snowboarding?
Mountains.
So it's kind of like that. Mountains have slopes, so M, that's the letter we use. And again, we're looking at the rise over the run. The greater the rise, the greater the steepness, right? Which on a coordinate plane is the change in the y, up and down change, over the change in the x. Okay? There's one other little mathematical way we can write this, so I'm leaving that hidden for a moment, and we're going to go try to find it on a coordinate plane, and then we'll come back here, so leave a space here for the mathematical way to find slope, okay? And we're going to come over here and try finding slope of this line. So I'm going to pause the video, you pause at home, and take this down before we find it, okay? Okay, so before we show the mathematical, the algebraic way of finding slope, let's use what we just said slope is. Slope equals the rise over the run. Rise is up and down, run is horizontal, okay? And when we find slope, we read graphs left to right. So if we start at the left point, -2, 1, and we travel to the right point, which is 0, 0, we need to ask how far is the rise between -2, 1 and 0, 0. Actually, are we rising at all going from left to right here? We're actually going in what direction? Down. And how many places down did we travel? We're traveling 1 down, right? So we have a -1, we go down 1, and then when we move horizontally, the run, how many places? 2. Good. So really the slope is -1 over 2. If you are given a graph like that, it's really nice. You can just look at a point on the left and a point on the right and determine what is your rise and what is your run when you move between those ones. Pretty easy, okay? But you can also do this if I just gave you those points and no graph. And that can save you a lot of time because you don't have to go make a graph. You could just take those points and use them. So let's try it that way. In order to find slope, we're just finding the difference between those 2 points, okay? So we have, let's call this point 1, x1, y1, and this point 2, x2, y2. That's another way of naming them, okay? We need to find the difference between the 2 y values, and we'll find that up and down difference, that rise difference. And we can do that just by subtracting them. We could take the second y point and subtract the first. And then we could do the same with the x values, x2 minus x1. Okay? So go ahead and jot that down. That's a super important formula that we're going to use over and over again. That's the slope formula. So let's try putting in the values for this problem. What is y2? Anybody shout it out. What is y2?
Y squared.
What number goes with y2? Here's the point here, 0, 0. So what goes with y2? 0. It's just 0. That's this number that goes with the y2, right? And so what number goes with y1? Which one is the y here?
1.
It's 1. See that? Okay, so we have 0 minus 1. That's our y values. And now we look at the x values. What's our x value in the second point here? 0. And we're going to subtract the x value from the first point. What is that? -2. You got it, yeah. -2. Okay, so what is 0 minus 1?
-1.
And what is 0 minus a -2? Isn't that plus a positive? We add the opposite, right? And we have 2. Now, isn't that the same slope we found by looking at the graph? Good. So we can see that if you have a graph, you can actually draw your rise and run in like a little triangle, and you can find it moving left to right. But if you don't have a graph and somebody just gives you two ordered pairs, you can find your slope by plugging them into this formula. Okay, Olivia? Use this again. So let's go back and put that little formula for finding slope in the rule box about slope, so we can refer to it there. Be sure to box that up. Okay, so you find 2 points on the graph. You were given 2 points on this graph, see that? And I chose to name this point the first point. So this is x1, this is y1. And I chose to name this one the second point, x2, y2. Do you know it doesn't matter which point is point 1 and which point is point 2? It doesn't matter. If we had named them the opposite way, we would have switched their places in this, and we would have still had the same slope when you do the math. So you don't have to worry which point you name point 1 and which point you name point 2. Just make sure you name one point 1 and one point 2 and plug it into your formula, that's all. Okay? To find your slope. So let's try that here without graphing. We have 2 points. What's the slope of the line that these 2 points are found on? Okay? So when you're given this question, what do we want to start with? What are we going to write down first? Izzy? The formula. So can you say it? M equals y2 minus y1 over x2 minus x1. So you write it down. That's your plan. Okay? And then the next step might be to go over to these 2 points and kind of name them, right? Which point, what do we want to name this first point, -3, -4? Do you want to call that point 1? Okay? You don't, it doesn't matter. You could call it point 2. It doesn't matter. But because it's the first one, let's just call it the first point. So this will be x1, y1. And this point over here then will be x2, y2. So we just write that down so we don't forget which point is which. Okay? Now we're going to come over and substitute what we just named. So who can tell me what number is y2? Stuart.
2.
Good. And we're going to subtract. Who can tell us y1? Jake. And there it is, -4. Good job. Well, no, you were right when you said -4, but I think what you're saying is we're subtracting negatives, so can we add a positive? Yes, but we'll leave it this way right now as we're starting, so everyone understands that we're putting a negative number into a place where there was subtraction. So we'll leave it alone for just a second, okay? Now let's go down to the x's. Who can give us x2? Will. Good. And x1, Ryan.
-3.
Good job. Okay, so now that we have substituted these known values, now we can go change our subtraction like Jake said, right? We could change this to adding the opposite, so it's actually positive. And the same thing is true in the denominator, we can add the opposite. So 2 plus 4 is, and 5 plus 3 is? 8. And can we reduce that? And when we reduce it, we get 3/4. And there you go, you have the slope. This line, if we went and graphed it on a graph, has a slope of 3/4. Up 3 and over 4. Okay? Jake? Okay, we're going to find the slopes of these two. Go ahead and pause and come back and check our answer. Remember, when the 0 is under, then it is undefined. But when the 0 is in the numerator, then the answer is 0. 0 can be divided by -4 how many times? 0 times. Okay? We have special cases. Vertical and horizontal lines. So let's talk about what their slopes are. So when we graph x equals 2, we start at 0, 0, and which way do we travel? Where is x equal to 2?
Right.
Right, okay, so right 2, here's a place where x equals 2. And where else does x equal 2? I'm hearing down and up, excellent. So you're right, it is this type of a line, okay? Good job. And so when we look at this type of line and try to figure out its slope, remember slope is rise over what? Run. Good. So is there rise in this line? If I go from this point to this point up here, is there rise?
Yes.
I went up 3, right? And then is there run?
No.
So I went up 3, and what's the run? 0. So what do we call this slope? Undefined. Good job. So all vertical lines have undefined slopes. Okay, it's just a free fall or a straight up jump. Okay? The second one says y equals -3, and if I start at 0, 0, where is y equaling -3? Is it to the left? Is it down? It's down, isn't it? Right here. And where else is y equal to -3? Left and right. Good. So we have a horizontal line right at y equals negative. It should be on the -3. The smartboard's a little not calibrated there. And so now let's talk about the slope here. If we travel from one point to another, is there any rise?
No.
Looking here, is there any rise? No, we have 0 rise. Is there run going from here to here? Let's say it's a run of 3, right? We moved from this point to this point. So what is 0 over 3?
It's 0.
Can we say it's 0?
Yeah.
Yes, we can. M equals 0. 0 slope. So when you have a horizontal line, there is 0 slope. This is the final summary of your 4 types of slope. So just quick little sketch. You don't have to label numbers in each direction right now. Just x, y, x, y, x, y. Here it is. Little sketch. And we're going to say what type of slope are each of these. And when we consider slope, imagine a little creature. We have a little creature with antennas. And this little creature travels on our line. And when the little creature travels, it always goes from left to right. Okay? So when this little creature is traveling here, left to right, is it going positive or negative?
Positive.
It's going positive. So this slope, when you see that type of slope, is positive. And when the little creature goes from left to right here, left to right is how we always read these things. It's going in a negative slope. Good. And we just talked about these last 2. So when the creature is going along here, what type of slope is it going positive or negative? No, it's going 0 slope. It's got a 0 slope. And when the poor little creature is doing this, it's a free fall, right? And we call that slope undefined. Okay? Straight up and down is undefined.